Good morning students, welcome to Konnur online classes. Today we can discuss a very important concept, that is permutation and combination. New topic, permutation and combination. Here these two words are very important to learn. Here probability concept. First we know that these two words meaning, then only we can study the concept of probability. Permutation means, here it is the arrangement. Here arrangement is called permutation, and selection here selection is the combination. Here consider m things and m thing, in which m thing arranged with n thing is called permutation. If those m things are there in which n things are selected are called combination. Here in with m things we can arrange with n thing is called permutation, and combination means here m things are present in which n things are selected is called combination. Here first come permutation. In this section, arrangement of elements are called permutation. Here, before going to start permutation, first we know that the fundamental principle of counting. Fundamental principle of counting. Here, this is a very first one. Here it is a multiplicative principle of fundamental principle of counting. In this one, here m thing arranged with m thing in how much ways? That is m into n ways. Here m into n ways. Here the m and multiplicative process. Here m thing is arranged with n thing. Finally we get m across n things are available. Here for additive operation, for addition, here mutually exclusive things are there. Here m and n are the mutually exclusive things. In that way we can arrange m plus n ways. On the basis of fundamental principle of counting, we can choose two problems belonging to one is multiplicative, another one is additive one. Here, if a die is thrown and then a coin is tossed, a die is thrown, a coin is tossed, find the number of all possible outcomes. Suppose here in this case a die consists of, there are 6 possibilities, 1, 2, 3, 4, 5 and 6. A coin is tossed, total possibility is, one is head, another one is a tail. Suppose at that time a die is rolled as well as a coin is tossed. Total possible outcomes are here 1H, 2H, 3h, 4h, 5h and 6h. These are one type possibility. Another one is one tail, two tail, three tail, four tail, five tail, six tail. Here, that's why in this, to avoid this one, we can choose fundamental principle of counting. Here, if a die is thrown, total possibility is 6. Entire coin is tossed, total possibility is 2. According to here, this is a m ways. Here, this is also n ways. Here, in fundamental principle of multiplicative process, here m cross n possibility, that implies here 6 into 2. There are 12 ways to arrange these elements. Arrange these elements. Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here, this is the fundamental principle of counting for multiplicative process. Here, in additive process, in how many ways can you choose a number from 1 to 20? 1 to 20, which are multiple of 5 or 7. 5 or 7. Here 1 to 20. Consider 1 to 20. A numbers multiple of 5 are 5, 10, 15 and 20. Here these four numbers are multiple of 5 and 7, 14. Or these two numbers are multiple of 7. Here these are unique element, or these are unique element are mutually exclusive numbers. That's why there are possibility we can choose 4 plus 2. There are 6 ways to arrange. 6 ways to arrange these numbers. Here, these two are the two examples for fundamental principle of counting for a multiplicative process as well as additive process. Next concept is factorial notation. Factorial notation. Here, consider n factorial. N factorial means here we can written as n minus 1, n minus 2, so on up to 3, 2, 1, 3, 2, 1. Here, this is also written as n factorial is equal to n minus 1, n minus 2 factorial. Also we can written here n factorial is equal to n minus 1 factorial is also right. For example 4 factorial. Here we can write it as 4 into 4 n minus 1, 4 minus 1, 3, then n minus 2, 2 into 1. Here, of course, last we get 1 to extend up to the result is comes to 1. 5 factorial. 5 into 4 into 3 into 2 into 1. Here, this is the factorial notation. For example, 3 factorial. Here, 3 into 2 factorial. Also, right. For example, to find the value of 10 factorial, 8 factorial divided by 6 factorial. 8 factorial. Here 8 into 7 into 6 factorial divided by 6 factorial. Here 6 factorial, 6 factorial get cancelled, we get 56 is our answer. Here in this case we can choose. Come to permutation point. Permutation. Here permutation can be defined in the form of one formula, that is NPR. NPR means there are n number of terms are there, n number of terms are there in which are ways to arrange. There are n number of terms or n number of things are there. They are arranged in r times. They are arranged in 6 r times. That's formula is n factorial divided by n minus r factorial. N minus r factorial. Here, this is the very important formula to determine thing. NPR is equal to n factorial divided by n minus r factorial. Here, suppose r is equal to n. R value changes to n. That implies NPN is equal to n factorial divided by n minus n factorial. Here, this is NPN is equal to n factorial, n minus n, 0 factorial. We know that 0 factorial value is 1. NPN is equal to n factorial. Here, this is one important formula. And also, r changes to 1. That implies NP1 is equal to n factorial divided by n minus 1 factorial. Here this is written as n minus 1 factorial divided by n minus 1 factorial. Here n minus 1 factorial and n minus 1 factorial. NP1 is equal to n. Here this is our another formula. NP1 is equal to n. For example, 5P1 is equal to 5. Definitely we can write 5P1 value is 1. Then to find 5P3 value. Then according to our principle, NPR is equal to n factorial divided by n minus r factorial. Here, in place of n, 5 is there. In place of r, 3 is there. Substitute value 5P3 is equal to 5 factorial divided by 5 minus 3, 2 factorial. That implies 5 into 4 into 3 into 2 factorial divided by 2 factorial. We can cancel 5 into 4. 20 into 3 value is 60 is our answer. Here NP3 n factorial divided by n minus 3 factorial is equal to 210. Then here find the value of n. If NP3 is equal to 210. Suppose we know that the formula NPR is equal to n factorial divided by n minus r factorial. In place of r, 3 is there. Here n factorial divided by n minus 3 factorial. Suppose we can extend n factorial n minus 1, n minus 2 and n minus 3 factorial divided by n minus 3 factorial. Here n minus 3 factorial, n minus 3 factorial get cancelled. Result is 110. That implies n minus 1, n minus 2 is equal to 210. Suppose n is equal to 7. n is equal to 7. 7 minus 1, 6. 5. 6 into 5, 30. 30 into 7, we get definitely, we know that the value 210. That implies, confirm that n value is 7. n value is 7. In the same problem, if np3 is to np2 is equal to 3 is to 1, then find the value of n. We can arrange np3 divided by np2 is equal to 3 divided by 1. We can arrange these terms according to formula n factorial divided by n minus 3 factorial whole divided by n factorial n minus 2 factorial is equal to 3 by 1. Here n minus 1, n minus 2, n minus 3 divide minus 3 factorial n minus 3 factorial whole divided by n minus 1, n minus 2 factorial divided by n minus 2 factorial is equal to 3 by 1. Here n by 2 factorial, n by 2 factorial. Here n minus 3 factorial, n minus 3 factorial. We get n minus 1, n minus 2 whole divided by n minus 1 is equal to 3 by 1. Here n minus 1, n minus 1 get cancelled. That's equal to here n minus 2 is equal to 3, n is equal to 3 plus 2, n is equal to 5 is our answer.